Alright, binomial theory. So a binomial is a polynomial with two terms. Okay? Example, x plus y. Okay? So a polynomial has lots of terms. This is a binomial, so it's got two terms. Alright, lovely jubbly. In principle, we can raise this binomial to any power and find the expanded version of it. So we could have x plus y all to the power 0, or we can have x plus y all to the power 1. We can have x plus y to the power 2, we can have x plus y to the power 3. Yes, these are all different terms. They're not all of one. They're different. So we could do that. How would we do that? So what would be x plus y all to the power 0? Careful. 1. Okay. Anything to the power 0 is 1. Yes? Yeah. If we had x plus y to the power 1, what would it be? X plus y. X plus y. Well, what's going to happen here is when we start to get to the square, what do we have to do? We need to do FOIL, yes? So we'd actually have to start expanding it. Again, with the x plus y cubed, we'd have to have our brackets and we'd have our expansion. Yeah. Oh, okay. I think we're doing it here. Oh, no, we're not. Okay. Let's do it here then. Oh, no, we are. I said here. No, I've already put the answer. I said, but finding the expanded version of any higher power is very tedious. Really, never tedious. Yeah. Boring. And how would we do that? Okay, well, if we were to do x plus y squared, yeah, we'd use FOIL, so that's x squared plus xy plus xy plus y squared. Yeah? Yeah. What do you mean, huh? F, first, outer, inner, plus. Yes? And this simplifies to be x squared plus 2xy plus y squared. Yeah? Right. Now, if you were trying to do x plus y cubed, you would focus on two of those brackets to start with. Yeah? Which we've just done. Right. And multiply that, each one of those, by both of these two. Yeah. So you would do x squared multiplied by x, 2xy multiplied by x, y squared multiplied by x, and then x squared multiplied by y, 2xy multiplied by y squared multiplied by y. Okay? And then join like that. So that's how you would do it. But as you can see, that's just going to the power of 3. Boring, like, oh my gosh, very, very easy to make a mistake. Yes? So what we want to try and do is to try and find a quick method. So this is where we're going to use the binomial theorem. So we're looking at x plus y to the power n. So n can be any positive integer. What's integer? 1. So if we were to expand these, we get 1, x plus y, x squared plus 2xy plus y squared, x cubed plus 3x squared y plus 3xy squared plus y cubed. Trust me, these are the answers. I've then given you even further answers. Now, what we want to try and do now is to compare these values here to what we started off with. Is there any kind of connection? So you're going to just look at them, discuss things. I've given you a few prompters. I want you to think about how can we describe the number of terms going to the general one. Like, so have a look, how many terms are there in each of those? How does it relate to this number here? Okay? You put them in front of you, so I didn't know that. Have a look at the powers of x. Okay, so look at the powers of x for each of those terms. Is there anything that's special about it? Do you notice anything happening? No. Look about the powers of y. So I'll give you a few minutes just to chit chat amongst yourselves, and then we can come back and discuss. Alright, so what did we discover? So first of all, how would we describe the number of terms? So we go through it as you. Okay, so
whatever is power.
Yeah, so
Right.
for our general one, we call that power n.
Power n is going to be an extra number of terms, like one extra number of
So how would I describe that?
n plus 1.
Lovely.
What on puzzle?
Excellent. Yeah. So just by looking at something, you can see how many terms there's going to be. Alright, so if this was a power 9, you have 10 terms, etc. Now, what's happening with our power of x's? Anyone want to say Katie?
Victoria's the same as power of the binomial.
For each term,
So, yeah, sorry, the first.
so the first term,
Yeah.
yeah, so the first term it matches this power, yeah? Did anyone notice anything else? Fine.
Yes. If you go like across the number sentence, if you look at the x values, they decrease by a number. So if we take example x plus y to the power of 5, it starts x plus y to the power of 5.
This one
That's the
here.
last number sentence. It goes down from 5, 4, 3, 2, and it's a little secret one right there. So it's
And then what's this one?
and also 0.
Nice. Okay, so did you all notice that?
No.
Maybe some of you noticed that it matched, that it started at 5,
Yeah.
but perhaps some of you didn't notice that you can see it's decreasing. So here it starts at 5, but then it's a 4, a 3, a 2, a 1, a secret 1 as I said, and this one goes down to 0. Yes? Well done, Malai. And Giselle. How about the powers of y?
It goes up.
Oh, interesting. So how does it start? What's the power of y in these first terms?
0.
And then
1, 2, 3, 4, 5, and 6.
and it ends at the power of the n.
The n. Yup.
Okay? So if we were to describe it here, so remember we're describing the powers of x, they start at n and decrease by 1 each time to 0. And the powers of y start at 0 and increase by 1 each time to n. Alright, so there's some patterns that we've noticed. So already that means that our expansions are going to be heaped quicker when we're doing them, because all we need to do is start with our highest power and decrease the first term, and then start with 0 and increase the second term. Lovely. Now, what about the coefficients of each term? This is a hard one, and I'm not expecting anyone to come up with the solutions here. So what's the coefficient of x and y here? 1, yeah? And then so we've obviously got 1s on all of these ends. Does anyone recognize?
Oh, I just saw that it was like, it would be like, you know how you like count down to the middle, so it'd be like 1, and then it would be like n, and it'd be like 2 times n in the middle. You know what I'm saying? Well, not 2 times n, but it would be like, it would go into the center. You know what I'm saying? So like, it would go
You mean it goes up and then down again in the same pattern? Is that what you mean?
Yeah.
Okay, yeah. But does anyone recognize those numbers?
The square numbers.
They're not
Prime.
Yeah.
What's the other different number?
as soon as I go to the next page, it's going to give it away, I believe.
Oh,
Okay.
Pascal's triangle.
They follow Pascal's triangle.
Oh. We learned it in math investigation.
Ah, yes, very likely.
That was like in your classroom. Indeed.
Now, oh, we haven't got it all. Pascal's triangle. So Pascal's triangle starts with a 1, and then it's a 1, 1, and then a 1, 2, 1 on the right hand side, I think, isn't it? Yeah. And then a 1. How does it form?
2, 3, 2, 1.
3, 3, 1.
Oh.
Remember, it's the 2 above. So this would be there's always a 1 on the outside. Then this would be a 4, 6, 4, 1, and then a 5, 10, 10, 5, 1, and so on and so forth. So 1's always on the outside. So it starts 1, 1, 1, and then we're adding the 2 numbers above it to get the 1 underneath. So the numbers always go in a gap. Yeah. So that's how Pascal's triangle is formed. But that in itself is also a little bit tedious to try and work out what these numbers are. So they actually do follow, there's a way that we can find them using our calculators. Do we all have our calculators today? Nope.
Yeah.
Everybody is all
Again, with lower values of n, it will be easy to determine the values of the corresponding row in Pascal's triangle, but with larger values, it's more difficult. But we have our counts. Now, you will find. Oh, now I've got to find where they are. What we're going to do is we're going to use a function on our calculator called we're looking for NCR. Okay, so NCR. Now, N indicates the row that we're talking about of Pascal's triangle. So if we went back up to look at here, this row would secretly be row 0. This row would be row 1. This would be row 2, 3, 4. Now, notice, well, hopefully you'll notice, that the row number is the same as the power. Okay, so this was, remember, row 0 when we had power of 0. This was to the power of 1, power of 2, power of 3. So the first number, the top number, n, is the row number. Okay, the r would be the column number. Again, when we talk about the columns, we start labeling our columns at 0 as well. So this number here, this 1, would be column 5. So column 0.
Is this husband?
No. This would be column 1, column 2, column 3, column 4, column 5.
Miss, I have another question.
Yeah.
Is column 3 1, 4, and 10?
No. Column, no. So,
How do you do columns?
okay, so we do row and column. So if we're talking about row 3,
Yeah.
that's this one here. So that's column 1, 0, 1, 2, 3.
So it doesn't include the numbers above.
No, we're just talking about one particular row. All right, now what we need to do is know how to stick it in our count. So can you get me one of these bad boys? So like just a document.
Yeah. Oh, there goes next.
So we want to actually calculate something. So
No, but it's gaps. Right.
now the kind of situation that we're trying to establish is we want to work out what number should be here. All right. So that's what we're trying to do. So we say to ourselves, right, okay, it's row 5 because this is 5.
Okay.
So we'd be trying to find the value of 5, and then we have to establish which number this is. So this is 0, 1, 2, 3. So to find this particular number, we would try and find the value of 5, and it's called NCR. So it's NCR. So it's 5C3. That's what we're trying to find. So we're trying to find the row 5, position 3. Where it's 0, 1, 2, 3.
Okay.
Does that make sense now?
Yes.
What do you mean, where did you get that from? Because we said it's 0, 1, 2, 3. We knew it was this position here. It will become clearer when we do more examples. Yes? If we wanted to find this number here, what would we be typing in?
1, 2.
So what's the top number?
6.
We didn't that without moving your lips. And then what would the bottom number be? Remember, this is 0. So we would be typing into our calculator 6C5. And hopefully we're going to get these answers in a second. Okay? Right, so now we need to know how to put it into our calcs. Alright, so your calc, I'm not as okay with these.
Would it be an equation where it's like 2x plus y equals or something?
Oh yes, we're going to get more complicated, don't worry.
Like Giselle, we start off like.
Alright, so did we all get our screen that gets this up?
Yeah.
Where it's got actions, number, whatever it is. So we want probability.
Oh, wow.
Okay? And then we want combinations. Now when you type that, when you hit that, it says NCR.
Right.
Yes? Now, let's open up a bracket. So this is where we have to say, right, well, let's look back at what we actually want to find. So if we want to find 5, 3, we would, in our calc, put 5, comma, which is down here on the left, 3, and press enter, and lo and behold, it was the number 10. But secretly we knew that, didn't we? Yes, because we knew that that was the value we were looking for here. So if we were to type 6, 5, we should get the answer 6. So should we practice that just to make sure? So I'm going to copy and paste. What was it? 6, 5 was it? There we go, 6. Lovely jubbly. So that's how we would use our calcs. Now, we do know that we have non-calc papers, so we can't always do NCR. So if that's the case, then it could be the situation where you would have to draw out your Pascal's triangle. If it's on a non-calc paper, I can't imagine it would be much higher than a power 5 or 6. They wouldn't ask you to go that high on your Pascal's triangle. It may actually be worth, though, probably learning something like row 4, so you can start your Pascal's triangle from there. Do you see what I mean?
Yeah.
So if you remember the 1, 4, 6, 4, 1, then you can carry on your Pascal's triangle. You don't have to start 1, 1, 1, 1, 2, 1, okay? Because if you're going to try and find row 7, it's much easier to start here at row 4. Yes? However, as I said, you can use this formula. Now this is in your formula booklets, so you get given this. So this is how you would find these values. We seen the exclamation mark before? That means a factorial. So what that means is that 5 factorial would be the answer to 5 multiplied by 4 multiplied by 3 to 1. Okay? So if we were trying to find, well, let's do one of the ones we just did. What were the ones we just did? 6, 5? Okay, thanks. So let's do 6. Oh, shush now. Okay, so if we're trying to find 6, 5, that would be 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Hold your horses, don't panic. I'm not going to ask you to calculate that just yet.
Okay.
Now, 5 would be 5 multiplied, don't work it out. Okay, so the R is the bottom number, so that's 5 to 4 times 3 and then this is going to be 6 take away 5, so that's just 1.
But that's factorial.
What's 1? Because it's 1.
But if it was like, let's say if it was on.
So this was 8, 3, then you would have 5 times 4 times 3 times 2 times 1. Should we change this number? Is that confusing?
No, I just need to make sure that like that's what was happening.
Okay. We're good?
Yeah.
Alright, so if you were asked to do this again, I wouldn't say work out all these numbers and then do some division. Because we've got this on the bottom, we've got this on the top.
Okay. So 6 over 1.
So 6 over 1, which is 6, which we knew anyway. Yes? So you want to go for easy options when you're doing these. Okay? But it could well be the situation that would be on paper 1 and you may need to know this. Alright, so just be aware that that's all cheeky and you can do it. So we know how to do it on the calculator, yes? Yep. Oh. So probability, and then it was combinations. Okay. Lovely, Jodie.
Good student, I already looked at all.
Right, so we're trying to find the value of 4, 3 using Pascal's triangle. And we know that this is 0, 1, 2, 3, 4. So we're looking at this row. And then 3 is 0, 1, 2, 3. This position, so it would be the value of 4.
Oh, really now? Okay.
So 6, 2. So that would be 6 factorial over 2 factorial multiplied by 4 factorial. I did those subtractions in my head because I'm super speedy.
Hold on a second now.
So that's 6 times 5 times 4 times 3 equals 2, 1. Yeah, so far so good. And so obviously I can cross off the 4 times 3 times 2 times 1. And then I can see I've got 6 and 2 here as well. So I've got 3 and 1. So I've just got 3 multiplied by 5, which is 15. Or you could have obviously done 30 over 2, which is also 15. So whilst this looks crazy and scary, the factorial business, it's actually very doable. Okay, so using the calc. So yeah, get rid of those instructions, they're a load of rubbish. So we've got, oh yeah, I just did it straight away. I should go through the whole thing, shouldn't I? Okay. So menu, probability, combinations, and then, oh, what was it, 25, 8?
5, 8.
And that's a big fat number, 108, 1575. 1575. So there we go, there's our answer there.